As another problem set, in this module we are interested in determining the performance of the overall communication channel, which is based on TCP, which determines the TCP timeout interval based on the estimates and samples. We are also going to cover a problem in which we'd see how TCP flow and congestion control could potentially prevent a scenario of congestion and overflow in the network. The reference that I chose is by Kuros and Ross. Let's look at TCP timeout scenario first. Suppose that on a communication channel, 5 measurements were made for determining the sampled RTT. You know that sampling is done as a measurement strategy using the timestamps. The measured sampled RTT values are shown to you here as 106 milliseconds, 120 milliseconds up to 115 milliseconds. On the basis of the sample, you can compute the estimated round trip time for a value of alpha as 0.125, and you can assume that the last estimated RTT measurement was 100 milliseconds. Once you are done with that, then compute the deviation RTT after each sample is obtained to determine how erratic or how fluctuating these measurements are. You can assume beta as 25%, and you can also assume the deviation to be 5 milliseconds before these 5 measurements were made. And on the basis of the deviation constant and the estimate, determine the TCP timeout interval. Now we look at the TCP flow and congestion control strategy. Suppose that there's a host A which is interested in sending a very large file to B over a TCP connection. If the timers never expire and then there's no packet loss, it means we would not see TCP retransmission strategy and TCP slow start and congestion avoidance mechanism to be triggered. If we denote the transmission rate of the connection or the communication link between A and the internet by R bits per second, and if you also assume that A is transmitting at S bits per second, which is 10 times the rate that the internet link can support. If you also assume that the receive buffer for this scenario at host B is large enough to accommodate 1% of the file. Now it is left up to you to determine, is it possible that A can send data to B at rate S bps per second? If not, how can it be prevented? Can it be prevented by flow control, congestion control, or do you see a mix of these to be at work? You need to explain this in narration.